Good morning, dear students. Today we'll discuss about the topic called inverse Z transforms. So in inverse Z transform, there are two methods. One is the partial fraction expansion method and the power series expansion method. So today we will discuss about the partial fraction expansion method. This partial fraction expansion method depends upon the value of numerator and denominator. So numerator will be indicated by m and denominator values will be indicated by n. So if m less than n, if the value of m is less than n, then directly the problems can be solved through partial fraction expansion method. If not, if the value of m is not less than n, then we have to go for long division method and bring that powers to a normal, that is m less than n order. That means if the value which is there in the numerator is 1 and if the value which is there in the denominator is 2, then you can solve the problem using partial fraction expansion method. If the value in the numerator is 2 and the value in the denominator is also 2, then m will be equal to n. Then we cannot solve the problems through partial fraction expansion method. So if you want to solve the problems in partial fraction expansion method, your m should be less than n. It should not be equal to or greater than n. That is the important condition. It should be less than n. This is about the concept of partial fraction expansion method. So first we'll take a small example. Find the discrete time sequence x of n, so which has z transform, that is x of z is equal to minus 1 plus 5 z inverse divided by 1 minus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2 with ROC mod z greater than 1. So this is the given equation. This is the given equation. So look at the numerator and the denominators. So first you check the highest power in the numerator. The highest power is 1, that is this is 1, and the highest power in the denominator is 2. So that means m is equal to 1 and n is equal to 2. Don't get confused with the minus 1. It should be taken as plus 1, and here it should be taken as plus 2 while taking the orders. So m is equal to 1 and n is equal to 2. So in this problem it is satisfied, that is m is less than n. Now we can solve the problems using partial fraction expansion methods. So before that we have to factorize the denominator. Look at these values. In the denominator we have 1 minus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2. So how to factorize? So take two numbers. First you take or assume two numbers. So when you multiply you have to get plus 1 by 2. So if you add, you have to get 3 by 2. So assume the two numbers. What are the two numbers? So when you add, you have to get 3 by 2. When you multiply, you should get 1 by 2. So what are those numbers? So look at this, minus 1 and minus 1 by 2. These are the two numbers. So you can add, first you add these two numbers, minus 1 minus 1 by 2. So minus 2 into 1, 2 minus 1 divided by 2. So you will get minus 3 by 2. So this minus 3 by 2, you got 3 by 2. Next, if you multiply these two numbers, that's minus 1 into minus 1 by 2, you will get plus 1 by 2. Minus 1 by 2 into minus 1, you will get plus 1 by 2. Here is plus 1 by 2. This is the way of factorizing. Now split up the denominator. X of z is equal to k1 divided by 1 minus 1 by 2, this value 1 by 2 z inverse, and k2 divided by 1 minus z inverse. We have assumed two numbers, that is minus 1 and minus 2. We just put that numbers in the denominator, 1 minus 1 by 2 z inverse plus k2 divided by 1 minus z inverse. Now we simplify this using partial fraction expansion method, that is k1 is equal to 1 by 2, you multiply with this. So k1 1 minus 1 by 2 z inverse into x of z. X of z is this one. This is your x of z. or else you can take this as x of z. This can also be taken. Now you simplify this, you will get 1 plus phi z inverse divided by 1 minus z inverse. After simplification you will get 1 plus phi z inverse 1 minus z inverse. So what happens if we simplify? I'll use small, I'll show you that 1 minus 1 by 2 z inverse into x of z is this thing minus 1 plus phi z inverse divided by 1 minus 1 by 2 z inverse into 1 minus z inverse. Look at this and this will get cancelled. Remaining is minus 1 plus phi z inverse divided by 1 minus z inverse. This is what I have written here. Now the value of z is 2 because we are calculating k1 value. So value of z is equal to 1 by 2. Z is equal to 1 by 2. If it is minus, you take it as plus 1 by 2. If it is plus, you take it as z is equal to minus 1 by 2. Vice versa. Now you substitute z is equal to 1 by 2. So when you substitute minus 1 plus phi 1 by 2 z inverse and 1 minus 1 by 2 to the power of z inverse. In place of z you just substitute 1 by 2. Then you will get minus 9. So in the same way you calculate k2. K2 is 1 minus z inverse into x of z. K2 is equal to, if you want to calculate K2, you just simplify, cross multiply, you will get K2 into x of z. Look at this, K2 into, that is x of z, 1 minus z inverse into x of z, 1 minus z inverse into x of z, and z will be given by 1. Here is 1. Here also it is minus, you take it as plus. In place of z you substitute 1, you will get minus, you will get 8. After simplification you will get 8. So value of k1 is minus 9 and value of k2 is 8. We substitute in this equation, we substitute values in this equation. K1 value is minus 9 and k2 value is 8 divided by the same values which is there in the denominator, that is 1 minus 1 by 2 z inverse and 1 minus z inverse. Now the ROC is lying outside the unit circles with a radius of 1. So minus 9. So this is in the form of 1 divided by 1 minus alpha. This is a right sided sequence. So if it is a right sided sequence, you can write in 1 by 2 alpha to the power of n into u of n, that is alpha to the power of n into u of n. In this form it is. So alpha value is 1 by 2. So 1. This is a form of infinite sum formula. So 1 divided by 1 minus alpha. This is in this form. So that's why I have written it as 1 by 2 all to the power of n into u of n plus 8 into u of n. Now we'll go for the second problem. Now find the inverse Z transform of the following using partial fraction expansion method. This is a given equation. Look at the ROC mod Z greater than 1. Here look at the highest power. Highest power is 2 in the numerator and also 2 in the denominator. That means m is not less than equal to n. So you have to make it as less than n. Use long division method. I think you have already studied long division method. Use long division method to bring it into a normal form. You write the numerator in the reverse order, that is z power of minus 2 plus 2z inverse plus 1. Now if you want to get 1 by 2 z inverse, if you want to get 1 by 2 z inverse, so what should be multiplied with this? Look at this, 1 by 2 z inverse minus 3 by 2 z inverse plus 1. You write, once again I will clarify that, you write, if you want to do the long division method, you write the numerator and denominator values in the reverse order. So that's what I have done here. Numerator values should be there in the block. Z to the power of minus 2, z to the power of minus 2, 2z inverse plus 1. Look at this, it is in the reverse order. And also you follow the same procedure for the denominator, that is 1 by 2 z to the power of minus 2 minus 3 by 2 z inverse plus 1. Now you start multiplying. So if you want to get z to the power of minus 2, what should be multiplied with this value, that is 2. If you multiply with 2, you will get z to the power of minus 2. Now you start multiplying this 2 with minus 3 by 2. So when you multiply this 3 by 2 with the 2, then 2 and 2 will get cancelled, and the remaining term will be 3, that is 3z inverse. Next again you multiply this 2 with the 1, you will get 2, and this will get cancelled, and change the signs. This will be plus and this will be minus. 2 plus 3 5, z inverse plus 1 minus 2 will get 1. So this is the way of bringing into a partial fraction expansion method. X of and the equation will be 2 plus this 2 plus 5z inverse minus 1 divided by 1 minus 1 by 2 z inverse into 1 by 1 minus z inverse. So now this is in the form of partial expansion method. Now you follow the same procedure what I did for the earlier problem. This is similar. This is a similar equation, so which I solved in the last problem. And finally you have to add this 2 with the final equation, that is minus 9 divided by 1 minus 1 by 2 z inverse plus 8 divided by 1 minus z inverse. This is what the value is. Thank you.